Hello and welcome to Solve Papers channel. I am Godfrey. In this video, I'll be solving Cambridge S physics questions. Topic is deformation of a solid. This is a June 2019 exam series. I encourage you to consider doing your revision topic-wise. Read a given topic and come attempt the questions when the content of that topic is fresh in your mind. This way, you'll get the most out of the topic. This is a sure way of getting your A-star, if that is your goal. I've seen this work with my students, and therefore I recommend it highly. And if you have not already subscribed to my channel, please click the subscribe button and hit the bell icon below. This way you will be notified every time I upload a new video. And I'm doing videos frequently, so you don't want to miss that out. It is how we get started. You'll always be getting this from me. And I've arranged these questions topic-wise. I always give you the paper from which this question was set. This question was set on paper 2-1 of May-June 2019. And this was question number 3. Of course, 9702, this is the code for physics in AS. Okay, so I'll let you know that. If you need to refer this to the past paper or to the Mackey scheme, you can use this to do that. Though I recommend, I don't recommend Mackey schemes. Mackey schemes are basically for examiners, not for students. As teachers will help your students if you so wish. Number 1, on deformation of solids. The variation with extension X of force F acting on a spring. Acting on a spring is shown. Force is on the y-axis. Extension given in meters is on the x-axis. We are told the spring of unstretched length 0.4 meters as one end attached to a fixed point. This end is attached to a fixed point here, as shown in fig 3.2. Right. Then a block of weight 2.5 newtons, this block here, is then attached to the spring. The block is then released and begins to move downwards at one instant. As the block is continuing to move downwards, the spring has a length of 0.7 meters, as shown in fig 3.2, 0.73 meters. Appears the block is still continuing to move downwards. So at one instant, the spring is 0.72 meters. Assume that the air resistance and the mass of the spring are negligible. Right? I will assume that. Air, for the change in length, of the spring from 0.4 to 0.72, use fig 3.1 to show that the increase in elastic potential energy of the spring is 0.64 joules. 0.64 joules. Okay, we are using this diagram here, 3.1. Using this diagram here, 3.1. All right, this is an extension, basically force graph. We know that we are supposed to show the increase in elastic potential energy of the spring is 0.64 when the spring is at 0.72. Of course, we know that elastic potential energy is given as half F times X. Of course, X is the extension. Therefore, we can get the extension by taking the difference here. 0.72 minus 0.40. The difference is 0.32 meters. And of course, so you go at 0.32 meters and find what is F. So at 0.32 meters, what is F? That is what we need to find. So you come to the graph here. You come to the graph here at an extension of 0.32. Of course, you need to get the scale correct. This is 0.35. So this should be 31, 0.31, 2, 3, 3, 3, 4, 3, 5. So it is here. So it is around here, that point. That is 0.32, the extension of 0.32. And therefore, you can see the force is 4 newtons. So you found the force. So bring it down here. So the force at 0.32, the force is 4.0 newtons. So then now you bring this value and this value over here. So you get F times 4 times 0.32. We are looking at the change in elastic, the increase in elastic. So when you multiply that, of course, this and this will cancel to get 2. 2 times that, you get 0.64 joules. So that is what we have shown, that we were supposed to show that the increase is this, and that is shown right there. Part 2. Calculate the increase in gravitational potential energy, the decrease in gravitational potential energy of the block of weight at of 2.5 newtons. GPE, gravitational potential energy, is mass times G times height. Of course, mg is the weight, which is given here, which is 2.5 newtons. Then the height is the change in the height is the change, okay, which you have gotten here as 0.32 meters. 0.32 meters. So then, of course, mg is the is the weight. So 2.5 times 0.32, and this gives us 0.08 joules. So the decrease in GP is 0.80 joules, was the units given there. Remember, the block is going downwards, so there is a decrease in gravitational potential energy. Part B, use the information in A1 and your answer in A2 to determine for the instant when the length of the spring is 0.72 meters, the kinetic energy of the block. Of course, the kinetic energy of the block will be the difference between the decrease in potential energy, and we have given this, it will be given 0.64 is the increase in elastic energy, right? So the difference between the GPE, which you have gotten here to be this, and the increase, GP is decreasing, okay, and this one is increasing. So the difference will give us the kinetic energy, the difference between the two, because we are taught to use Air part 1 and Air part 2 at when the length is at 0.72 to calculate kinetic energy. So kinetic energy is equals to GPE minus elastic potential energy. In this case, GP is 0.80 minus 0.64, which had shown up there. Therefore, when you take the difference, you find the difference is 0.16 joules, which is the kinetic energy, 0.16 joules. Right. Part 2 of B, we are taught to show the speed of the block. we have the kinetic energy, so now we can get the speed of the block. Kinetic energy is half mv squared. Half mv squared. Therefore, if we want the speed, our speed is twice the kinetic energy divided by mass, square root of that. Okay, so here we have 2 times kinetic energy, which is 0.16 divided by the mass. The mass is can get the mass. We know weight is, we had given weight to be 2.5 newtons, and we know that weight is equals to mass times gravity. Therefore, mass will be weight divided by g. In this case, will be 2.5 newtons divided by 9.81, and that should be our mass. So you can use that here. 2.5 divided by 2.5 divided by 9.81 right there. And when you do the calculation correct, you should get something like 1.1 meters per second. Make sure you confirm this with your calculator. So 1.1 meters per second. Of course, we give it to 2SF, and because all the values here are given in 2 significant fingers. Of course, this is 2SF. You don't write 0.8. 0.8 is equivalent to 1 SF. So you have to write 0.80 to make it 2SF. So everything here is given in 2SF, so you should give it also in 2SF. And that's it for this. There was only one question on deformation of solids in papers 2.1, 2.2, and 2.3 of June 2019. Don't forget, these questions are basically around 7 or so in every paper. So, as I've said, you can get these papers from softpapers.co.uk. Practice working out these questions. Don't just watch the video and then you feel you're good to go. And if you need my help, I told you where to get me at SP Academy. SP Academy. You can get me at spacademy.co.uk. I can help you with tuition if you are looking for a tutor. I can help you with that. So get me at that point, and I will be able to assist you. Great. Thanks for watching this video. Hopefully, I'll see you in my next other video. Cheers.